Spire title. I will be checking this on your test day. Make sure you have it all there in your spiral. If you don't have it there, I'm going to take off points. So make sure you have your whole chapter together. Here we go, page 66. Let me zoom in. Okay, it says for the probability of the length, it says the probability will be this one compared to the entire length. So it's like there's 3 sections in this one, so it's estimated that it would be like CD out of 3 sections, roughly, approximately. It just say the part that you want, so it's like part over the whole. The part that you're looking for over the whole will be the probability of something taking place. So if I look at the first example here, example 1, it says I find the probability that a point chosen at random on this segment FJ, this entire segment here, this is going from -5 all the way up to 7. That entire distance is a total of 12 units long. And it says what's the probability of choosing a point on random on this FJ that is also on GK, sorry. GK is at -3 all the way to 6, and from -3 to 6, that distance is 9. So to write my ratio, I'm going to put GK over FJ, which means this is 9 over 12, which reduces to 3/4. That is your probability that the point that you pick will be on both JK and FJ. Okay, if I go to the next definition, this is probability and area. The probability of, this is let J be a region that contains region M. So M has to be inside of the J. If point K is in J is chosen at random, then the probability that it is in the region M is the ratio of the area of M to the area of J. So for this probability of K in the region M, that means I need the area of M over the area of J for that probability. If I go to the example, that would be example number 2 for this situation. They say, okay, a golf ball is hit and stops on the green where the shadow area represents the green. A prize is won if it stops in the painted circle. The diameters of the green and the circles are shown at the right, so you can see that this diameter here is 75 feet, and this little white one or clear one here is 15 feet. So if the ball is equally likely to stop at any point on the green, what is the probability of the prize being won? So they want to know what's the likelihood that that ball is going to stop in this little bitty area compared to this entire green circle. So using this definition above where it had probability and area, I'm going to find the area of the small circle, which for that little small circle the diameter is 15, so the radius, that guy's radius will be half, which means that's 7.5. And then when I use this radius here, what's half of 75? That would be 37.5 is what I'll use for the entire circle. So the smaller one will be pi times 7.5 squared. I'm going to put that on top for the area of your circle. And then the area of your large circle, I don't know how to distinguish those different, will be pi, but this time 37.5 squared. Now I'm going to put this in my calculator and see what fancy stuff I can come up with. Okay, so I have placed it in my calculator, if I get that little light out of there, in that fashion. So if I push enter, it gives me 0.04 as an answer. Now I want this as a fraction, so let's see if I can make it a fraction. There's my fraction, 1 over 25. And you might be able to see that since there's pile on top and bottom, those cancel out, and all I'm left with is these numbers that will reduce to 1 to 25. That's the probability that the ball will land in this little white circle out of a total 25 times. Once out of 25. On the last example here, I have example 3, and that's where we're going to call it quits on this. It says, okay, estimating the area on the grid. Estimate, there's an important word. The homeowner's property is shown with a scale drawing. If a deer is equally likely to be anywhere on the property, estimate the probability that it is on the green grass. We want to estimate that it's going to be on the green compared to anywhere else on that particular property. I'm going to imagine this being a square so that I can say this area of the grass roughly is 1, 2, 3, 4 by a 1, 2, 3, 4, 5, 6, 7, 8. So the area of my grass is going to be 32 feet squared, or 32 units squared. I don't know if it's feet or inches. And then the likelihood, because it says anywhere on the property, if I'm looking at that, okay, if I look for the entire property, this is still 8 wide, but to go all the way from the edge of the water where we estimated it being a little bit higher, that is 1, 2, 3, 4, 5, 6, 7. So I'm going to say the area of the entire area. I'm going to put prop for the entire property. I'm going to say is a 7 by 8, which is roughly 56 units squared. Now I know it's a little bit shorter because of this, but we can assume that there's land right there to make this a square property. Alright, if I put that in my calculator and see if it reduces, I believe it does, at least by 2. I'm going to put it as a fraction. Okay, so put it in as a fraction. I'm going to simplify it, and it reduces to 4/7. The units cancel out, that leaves 4/7 is your probability. 4 out of 7 times that the deer will actually be in the grass out of 7 runs of it. Okay, if you're doing good with this, give me a big old check mark saying that you're doing just right. If not, then give me a big old X saying I don't understand this probability. Whichever is the case.